Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. In my last video on congruency, I had explained what congruency means, what is the meaning of corresponding sides, corresponding angles, and if two triangles are proven congruent, then corresponding parts of congruent triangles are also congruent, CP/CTC, and what is the meaning of that. I had also mentioned that there are 5 ways in which we can prove congruency. SAS is one of those methods in which if you are able to prove that the corresponding two sides are equal, like AB is equal to DE and BC is equal to EF, and intervening angle B and angle A are equal, then the SAS criterion is met and then these two triangles will be considered congruent. Now today let us see the usage of this SAS criterion, how we can use it. Okay. Which criteria you will try using for proving congruency depends on what is given and what is to be proven. Let's take this example where there is a rectangle ABCE and there is a point D on BC. AD and AC are connected and DE is also connected. Now what is given here is AB is equal to AD. This side is equal to this side. AC is equal to AE. AC is equal to AE. And angle BAD is equal to angle EAC. These two angles are equal. Now we have to prove that BC, this side, is equal to DE. Okay. Now, if we have to prove BC equal to DE, we will have to prove two triangles congruent, and then we will utilize CP/CTC to prove that BC is equal to DE. Now, which two triangles we should choose? Let's choose triangle ABD and triangle DEC. Now, if we choose these two triangles, then we will have AB, AD appearing and angle BAD appearing. In triangle DEC, DE will appear, DC will appear, CE will appear. Okay. Now let's see what is given. AB equal to AD given. So AB and AD are appearing. Okay. AC is equal to AE given. Is AC appearing anywhere? Not in this set. And this set also is not appearing. AE is also not appearing on these sets. Angle BAD is appearing, but angle EAC is not appearing in this triangle. Therefore, these two triangles are not right choice to prove congruency. Okay? Then let's try another set. Let's try triangles ABC and triangle ADE. If we choose these two, which all are appearing? AB is appearing, AC is appearing, and BC is appearing in this triangle ABC. In triangle ADE, AD is appearing, DE is appearing, and AE is appearing. Now let's try what is given. AB is equal to AD. whatever is appearing in that, these two are equal. That is appearing. AC is equal to AE is given. AC is also appearing and AE is also appearing, right? Also, what I have to prove? I have to prove BC is equal to DE. And that which has to be proven, that also is appearing. So therefore, these two triangles are the right choice. Okay. Now let's work on that. How will we prove congruency? Okay. So before we go forward proving the congruency, sometimes it becomes easy to draw these triangles once we have done the selection, to draw these triangles separately out of this whole set, because sometimes it becomes very confusing. So let's do that. We have chosen these two triangles, so let's draw these two triangles separately. Okay. So this triangle will be ABC and ADE. Okay. And in that we know that AB is equal to AD given, AC is equal to AE, that is also given, and I have to prove that BC is equal to DE. What is not given is this angle, the intervening angle between these two sets. Okay. So now, but it is given that angle BAD is equal to angle EAC. Look at this triangle. BAD, this angle, is equal to EAC, this angle. Okay. If we take this angle as X, can I write angle BAD plus X is equal to angle EAC plus X? If I add same angle on both sides of equality, my equality doesn't change. Now, angle BAD plus X will be angle BAC. And angle EAC plus X will be angle EAD. Okay. So now, if you look at this triangle ABC and ADE, which are these triangles ABC and ADE, which we have drawn separately. Now angle BAC becomes equal to angle EAD. BAC becomes equal to angle EAD. Okay. So in these two triangles, if we look at, then angle BAC is equal to angle EAD, and side AB is equal to AD. Side AC is equal to AE. Both these are given. One side equal to another side here in another triangle. Second side AC is equal to AE, and intervening angle are equal. Therefore, with SAS criterion, triangle ABC is congruent to triangle ADE. Now we can use CP/CTC observation, and from that, because this angle is equal to this angle, so corresponding side will also be congruent, means BC will be congruent to DE. BC will be equal to DE from CP/CTC. And this is what we had to prove. BC is equal to D, which is now proved. Okay. So with this example, you have clearly seen that what is the basis on which we choose any of these five criteria. In this case, we worked on SAS because two sides were given and one angle was also given, not exactly the intervening angle. Also, we need to learn and practice that which two triangles then we need to choose. Of course, that is also dictated by what is given and what is to be proved. Okay. When we apply these criteria and concepts, we should be able to prove any problem related with congruency. Hope the SAS is clear to you. We will talk about other criteria in next set of videos. Thank you very much.